Hello everyone, welcome to my channel Physics with NK Bhatt. To learn concepts of physics, subscribe this channel and press the bell icon button to get notified for every new video lecture. Good morning dear students. In the last video lecture, we discussed about diffraction of light. The fundamental concepts of diffraction we understood. In this video lecture, we will talk about diffraction at single slit that we discussed in the end of that last video. I will elaborate this particular topic in this lecture. The necessary condition for diffraction to occur is the size of obstacle is comparable to the wavelength of the wave. In case of light, since the wavelength of light is very short, that is of order of nanometer, so for obstacle it is quite difficult to see the diffraction effect. To understand diffraction of light, we use single slit, and in this single slit also the same condition must be satisfied, that you can see here when light passes through the slit of size comparable to the wavelength of the light, then diffraction occurs and the light enters into the geometrical shadow region. This is very important. After diffraction, the light enters into the geometrical shadow region. The diffractions at single slit are of two types. The first one is Fresnel diffraction and the second one is Fraunhofer diffraction. We will understand them one by one. So first I consider Fresnel diffraction. The difference between these two is of wavefront only. When we talk about Fresnel diffraction, then the wavefront which is we are getting after diffraction is a spherical wavefront. So to have the spherical wavefront, the screen in this arrangement should be close to the plane of the slit. The incident wavefront can be both spherical or plane wavefront, but the diffracted wavefront is spherical wavefront, whether it is plane wavefront or whether it is spherical wavefront. The diffracted wavefront is spherical wavefront. Try to understand this in this diagram. You can see a single slit here, its width is small d, and a plane wavefront is incidenting on it. Since the screen is placed closed, this is the screen and it is close to the slit. So incident wavefront is plane wavefront and diffracted wavefront will be spherical wavefront. In the second diagram you can see here the incident wavefront is spherical wavefront. The slit is again very close to the screen, or we can say the screen is close to the slit. So the diffracted wavefront will be spherical wavefront here. So when we talk about Fresnel diffraction, these two are to be major aspect to keep in mind, that in the arrangement for Fresnel diffraction, the screen should be close to the plane of the slit. The second one is Fraunhofer diffraction. In Fraunhofer diffraction, the diffracted wavefront is plane wavefront. That is possible only and only the diffracted wavefront is plane wavefront. That is possible only if the screen is placed far away from the plane of the slit. So screen is placed far distance from the slit, so that the diffracted wavefront is a plane wavefront. One more important thing or concept you should keep in mind, that both incident and diffracted wavefronts are plane wavefront in case of Fraunhofer diffraction. So to get the plane wavefront, the very simple method we can follow, we place the source also away from the slit and the screen is also away from the slit. So in that case both the incident and diffracted wavefronts are plane wavefront. So this is very simple concept, that how the diffraction occurs at single slit and what are the possibilities of diffraction at single slit. Condition is very simple, as it is the major condition for diffraction to occur. In place of obstacle we have slit here, So size of the slit must be comparable to the wavelength of the light. The meaning of size of slit is you can see the opening through which the light is passing. Here, this is the slit and this is width d. So this width d should be comparable to the wavelength of light. Here also, this is width of the slit. So the size of slit should be comparable to the wavelength. Here also, this is the width of slit. In the diagram, I have taken A as a width because in detail we will discuss about the Fraunhofer diffraction in the next video lecture. So I hope you understood the concept of diffraction at single slit, both Fresnel and Fraunhofer. In Fresnel diffraction, the diffracted wavefront is a spherical wavefront, and in Fraunhofer, both incident and diffracted wavefronts are plane wavefront. Thanks for watching this video. I hope you enjoyed the learning of this concept. In the next video lecture, we will discuss in detail about the diffraction at single slit in the section of Fraunhofer, and we will elaborate everything, that how the fringes are formed, what are the pattern of fringes often. So till then, keep watching, keep learning.